All right, section 6.2, polynomials and linear factors. What are factors? Do you remember?
Are there
That
the two
multiply.
things that multiply to make the sum of one number?
Cool. So like if I say 6, two factors of 6 would be 2 and 3, right? If I have something like x squared plus 4x minus 12, you can factor it into two binomials. So that it would look like x plus 6 and x minus 2. If you FOIL that out or multiply it out, you would end up with what you started up there. Same thing with if you multiply these two, you would end up with that. It can go both ways, in other words, right? You can factor going down to the factors, or you can multiply going back up to the product, right? So we can call this one product, and we can call these factors. Do you want me to write out a definition of factors?
No.
Okay. All right, so we're going to jump right into example 1. Write as a polynomial in standard form. And here's what we have. We have x plus 1 as one factor times x plus 2 as another factor times x plus 3 as our third factor. So just like when you were multiplying something like 27 times 13, you don't do it all at once. You do things like the 3 times the 7, 3 times the 20, 10 times 7, and 10 times 2, right?
Mm-hmm.
Or if I had something like 27 times 13 times 78, you can't just do it all at once unless you're plopping in a calculator, which is not what I'm talking about. You would have to do these two first, then the product of that times this, right?
Yeah.
That's going to be the same process here. I have to multiply 2 at a time. Then that product I will multiply by the last factor. Okay? So the first one is going to be foiling.
X.
Yep. What is it?
Squared.
Yep, x squared. And then x times the 2.
2x.
Yep. And then I'm going to have 1 times x.
X.
Mm-hmm. And I'm going to
Plus
have
2.
Yep. And that's still all in parentheses because that's all one factor or one product that's going to be multiplied by the x plus 3. Personally, it doesn't really matter which way you go. I like to go from the binomial here, but we need to combine these two also, and go this way instead of,
The big one.
yeah.
Yeah, I usually write on the other side.
So if I combine simplify this one first, it's x squared plus 3x plus 2, right? And that still times x plus 3. So I don't like to do this kind of distribution. I feel like it just gets a little bit cumbersome.
Yeah, I just wrote on the other side.
Yeah,
so I
yeah.
go this way.
Yeah, I do too. It's personal preference. Multiplication you can do in any order. So I'm going to go x times x squared is x to the third. X times 3x is plus 3x squared. X times 2 is plus 2x. I'm going to do 3 times x squared plus 3x squared. 3 times the 3x plus 3x. And 3 times 2.
Wait, 3 times 3x is what?
Sorry, 9. I apologize. Thanks. 9x. Good catch. And then I have some like terms to combine.
Mm-hmm.
The x to the third stands alone. So there's my x to the third. It's the highest power. It comes first.
Well, it can combine with the 3x.
No.
Oh, that's not to the third.
Right. So I like to
Alright.
visually see. I'm going to put squares
Wait,
around.
it's x to the third plus 3x squared.
Yeah.
And then x squared, there's
Okay.
There's
2 of them.
2 of the x squared. So I'm putting a square around the x squareds, and I'll put like a, I'm not even going to change color on you, triangle around the x terms. And then if you want to do a third one, you could do a circle around the constants. It doesn't matter to me. But just as a visual, those are the things that need to be combined.
So then you have plus 6x squared.
Mm-hmm. And plus,
then 11x
uh-huh.
plus 6.
Yep. So that's your final product. And it is already written in standard form because I have the highest power first, descending as you go along to the right. Okay? Questions on that one? Good. Pretty easy, I hope, right? So, example 2, personally again, I think this is the easier way. When we get into the next one, it's a little bit more challenging. It says write in factored form.
That's where you have the bigot. Factored form is what?
It's doing the
Factored,
opposite.
yeah, this is factored form that we started with before, with all the different, what I call bubbles, right?
Okay.
So here's the expression we have. We have 2x to the third plus 10x squared plus 12x. What do you notice right away?
That it's already
They all
in
are
the-
divisible by 2.
They're all divisible by 2. Cool. What else do you notice right away?
They all have an x.
Yeah,
So you can
right.
take an x out and you can take a 2 out.
Correct. So,
So divide by 2x.
yep, divide everything by 2x, but it doesn't go away. It's what a factor that
It's
we're
gonna
going
be
to
on the
plop out
outside.
front. Right. 2x pulled out of each one of those terms.
Yeah.
So you would have what left?
X to the second
Uh-huh.
Wait, x
plus
Mm-hmm.
5x
Yep.
plus 12.
Careful.
Or 6, I mean.
Plus 6, right. So I took the factor of x out of the last one and a factor of 2 out of the last one and every single one along the way.
Mhm.
So that if I multiply it back out, I do this, distribute it, I should end up back here,
Mm-hmm.
right? You should always be able to go backwards and forwards. Not always easy or pleasant, but you should be able to. Okay. But am I done?
No.
How do I know I'm not
You
done?
want little bubbles.
Because,
I need more little bubbles out of this part here, right?
mm-hmm.
Okay, so that factor, the 2x still stays. That's there. If you want to put it in parentheses so it looks more like a factor, you can. I don't care. And then how would I factor this? If you want to use the box, you can. If you want to do guess and check, you can. If you have a different method, you can. Doesn't matter to me. We put if you're doing the box method, x squared and 6, and then we have to figure out how to break up the 6 into these two parts here so that it adds up to 5x. So we know it's going to be x term and an x term
2 and a
because
3.
yeah, so 2 times
3.
3 is 6 and 2 plus 3 is 5. I need it to be positive for both of them.
So it's plus.
Right. So that my two factors would be x plus 2, x plus 3. Does it matter if I were to write it this way? 2x times x plus 3 times x plus 2. Does that matter?
2.
That's what I have written.
Do you see what I did different though?
You just what? I don't even know.
That I switched the factors. Does it matter?
Oh, no, it doesn't matter. It's
It
not
doesn't.
multiplying.
Right. What do you notice about these particular factors? This one, and this one. They are all what kind of expressions that we learned about the other day in the last lesson? What's the degree of them?
Oh.
Linear.
It's a degree of 1 that makes it linear, yes. So we're writing into linear factors. This one was a linear, all linear factors here too, right? We're going to do everything we can to always get down to linear factors. Linear factors become much easier to solve the equations when we get to that point.
So
All
that's
right.
all we had to do.
For example 2, yeah, that was all.
Mm-hmm.
All right, example 3. It's a real world.
Ooh, my favorite.
Okay, airlines regulate the size of carry-on luggage because space is limited in a plane's overhead compartments, right? So you have to have a certain size. It's usually, how do you measure those things?
Weight
Not just weight,
and
Width,
area.
the width,
size,
the
the
length, and the
height.
right. Okay, which determines the volume.
So volume equals depth times length.
Yeah, let me read the
times-
actual problem. Okay, so several popular models of carry-on luggage have a length of 10 inches greater than their depth to comply with airline regulations. The sum of the length, the width, and the depth may not exceed 40 inches. So let me write that. Sum of length and width and what do they call it? I lost it.
Depth.
Length, width, and depth. Thank you. Not exceed 40 inches. Assume that the sum of the length, width, and depth is 40 inches. We're going to graph the function relating the volume to the depth. We're going to find the x-intercepts and what do they represent. Okay, so we're going to say volume equals depth, hey, it moved on me. Depth times length times width. And it said in there a minute ago, it said that several popular models of carry-on luggage have a length of 10 inches greater than their depth. So we're going to say x equals the depth, then
Wait, why is X, why not D? Wait,
you can use D. I don't care. You want me to use D?
wait, oh, I thought we were defining them before. I'm like, why are we
I'm not going to
making
use D because I'm trying to use one variable
Yeah,
and represent it within depth, length, and width.
okay.
That's why I'm not using D.
Okay.
So I'm going to stick with x is my depth. If x is my depth, then based on what I just said a minute ago, x plus 10 is my length. Right? That's what they said within the problem. Luggage has a length 10 inches greater than their depth.
And then
There's the 10
the
greater.
width would be the,
And the width is a little bit more tricky.
40. Wait,
Width,
So wouldn't it be?
what'd you say? 40, what were you going to say?
I was gonna say, well, in the
40
problem,
minus what?
40 take away the length and the
Right.
depth, because that's how you'd solve it in the
So
bigger
it's
problem.
in words, it would be 40 take away the depth and the length, right? And we have expressions for those. So,
Depth is X,
yep. So we could say 40 take away,
X plus, and
X.
length we just said is X plus 10.
uh-huh. That was an ugly X.
So that could be 2X plus 10.
Yes. So 40 take away 2x plus 10. Simplifying as we go, and that was my width again. And maybe if we want to make it like my strategy of list out all your variables, length, there's your width, length, just so it's all in one spot, is the x plus 10, and the depth is my x. So there's my like key variable expressions, right? It's usually helpful to have them all in one spot. Okay, so we could say then, using this up here, the volume. Volume is depth times length times width.
Alright. Depth, so X.
Volume equals, I'm not gonna
X
scooch
plus
out,
10.
x times,
X
if I'm
plus
following
10.
up here. Yep, x plus 10 times 40, maybe we could leave it this way, 40, and I'll make this a bracket, just because there's parentheses within there. It doesn't really matter. Minus x plus, I'm gonna change it because we simplified it.
2X.
2x, thank you. 2x plus 10. Does that expression make sense?
Mm-hmm.
So, I'm not asking you to multiply it all out. You could. All I'm asking you to do is you go grab your graphing calculator. Type this whole expression in with those parentheses where they are. These that I switched to brackets can be still put in as parentheses. That's okay. So literally type it in as variable, your variable button, parentheses, variable button, plus 10. Go ahead and do this. And I'll add in a picture of the graph.
So you put it in this thing?
And y equals.
Y equals?
Mm-hmm.
So mine's like literally about to die and I've been waiting for a charger. So.
You guys and your battery's dead and whatnot.
X into 1 X. What do I do when I get in Y?
To y, what? Y equals, type in the equation we just came up with. Oh, you gotta turn off your
My
plots.
window.
Oh,
And you gotta change your plot to, your graph,
wait.
your window, I'm sorry, your window. I'm gonna write down the window dimensions that I would recommend here. X minimum would be negative 15. X max, I'd put in as 20. X scale, how many tick marks there is, but every 5. Y minimum, we'll say is negative 1500. Y max, we'll put at 2500, and then the Y scale, since I'm talking such big numbers, we're gonna go at 500. Okay, this should give you a decent picture of your graph.
Look at that.
Look, I love it.
Let me see it.
You get this beautiful, curvy
Beautiful.
thing that looks kind of like, let's see if I can do it. It goes through the origin, and it goes through, I'm gonna use two things.
Wow.
There.
If I
And
look
1,
at it.
2,
Oh,
4, 6.
it's gonna go.
2, 4, 6. So it goes kind of like this. Something like that, right?
Mhm.
Your calculator will spit out a much prettier graph than mine will, but it works, right? So, but what do the intercepts represent?
The X's.
What do you mean the x's?
No.
What about them?
How much room there is? Like
Think about what we
volume.
defined x was to be.
X was the,
The
depth.
depth.
Ah, right? That was right here. X is the depth. So, can the depth actually be 0?
No.
No.
What, can the depth actually be negative?
No. So
Can
it's
the
right
depth?
there.
Ah, so what was that?
This range right here.
Well, what number was it? So if you trace it,
15.
or if you, yeah, it's 15.
This
Or
is
if you're going by
15
your
right
x scale, which I was counting every 2 squares, so it made it bigger in here. There's 5, 10, 15. So at 15, so what did it
Your
tell you then?
X.
What's that?
Put 15 for your X.
Right, so but this is these values here are values that produce a volume of 0. Do you want a volume of 0?
here.
No, you probably want the maximum volume, don't you? Right? So what would you describe as a realistic domain? Domain, remembering, is like the x values that you're allowed to use. So a
within here
realistic
to
thing.
here. Like,
Yeah, Hannah's
at
pointing
0.
out. Yeah, Hannah's pointing from here to here is a realistic domain.
But a little further over. 'cause
Right,
they
so
have,
you
like,
don't
the-
include it. How do you say that you don't include it?
The little piranha guy.
So x would have to be the piranha guy, yeah.
Alligator guy.
X has to be bigger than 0 and also less than 15, right? Does that make sense? Realistically, it has to be more than 0. You can't have 0 as a dimension. And you're going to want it less than 15 because otherwise something else has to be 0.
Wait, I'm confused.
What?
Yeah, I'm a little confused.
No, that makes sense. It's gotta be within
Yeah.
here.
That's why it came up to 0 here.
Oh.
Exactly. Lily just plugged in 15 into this equation and came up with 0. That's what your graph is saying. If you use 15 for your dimension, one of your dimensions, it will be 0, your volume.
Hunty at the door.
So many animal distractions right now.
But that's like the cutest cat.
Yeah,
That's the
wait,
only
wait till
cat
the
I
end of the
like.
video. I'll put in a cute little picture. Okay, so, where was I? Okay, what's the maximum possible volume of a piece of luggage then? So really
15.
nope, we're zeroing in on the graph here because
Oh,
the graph,
the
remember, is
vertex.
representing the volume,
Oh.
right? So what would the maximum
vertex.
be? Right, the vertex. So it's something up in this area, right? Look for the greatest value of y that occurs within that the domain, the realistic domain of 0 to 15.
So it'd be right here. That whatever that is.
So
you
on your
traced it.
calculator, you have a max feature. Like you can trace it, and then let's see if I can find it easily.
For the graph.
Graph, yep, and then trace calculate maximum. It's like the second trace button, and then you need to give it a general approximation. Get close to it on the left, press enter. Get close to it on the right of the maximum, press enter, and then you press enter twice and you'll have a blinking little thing that, let me use black, a little blinking thing that looks like this, and like basically saying, is this about where you're saying the maximum is? And you say yes by pressing enter, and it will approximate it. On the bottom of your screen it will say, I'm writing at the top though, it'll say an x value and it'll give you a y value at the bottom. The x maximum is 8.931 blah blah blah, and then 2052.2 blah blah blah. This would be inches cubed, and this would be inches, right? Because this is linear, you're talking a dimension, and
Wait,
here you're
X
talking
is
volume.
inches cubed.
Y was volume, so the y value was the inches cubed.
Okay.
Remembering that
that's
the
what I
graph
have.
itself is representing the volume as you change the dimensions of the suitcase. right?
Mhm.
So you could have a suitcase that looks like this, right? Boxy. Or you could have a long, skinny one that's not very wide. Some people, depending on what you're carrying, right? Or you could have this real fat thing in short, something like this. So all of them will have a different volume. As you change the depth, or this I guess would be the depth, and the width, and the depth, and the width, and the height, depth, width. As you change them all, you're changing the volume, right? But you're only allowed, if you add them all up, they'll have to total less than 40, right? We use that to come up with different factors, here, here, and here, to give us our volume. So you press guess, you get this, that's approximately your largest volume at about 8.9 inches.
Mm-hmm.
So then if I'm asking then what are the other corresponding dimensions? If this is your depth, this is getting really messy. I'm going to go back up to my box. Let's approximate this to 9. Are you okay with that? Or even 8.9? We'll chop off the remaining stuff.
Mm-hmm.
So we can say 8.9 here equals x. Well, if 8.9 is x there, plug it in here, and you come up with some answers. You'd have 18.9 inches here, right, for the length.
Mm-hmm.
And then this one is a little bit more calculation going on there. Anybody want to try to do that real quick? If not, I can. So, what? 8.9 times 2 plus 10. And I'm going to take, so that would be the 40, take away 27.8.
It's like a baby furnace.
Which would be, don't go away, 12.2 inches. So your best bet for a suitcase to give you the largest volume is going to have those dimensions. 12 by 18, or close to 19, 12 by 19 by 9-ish. Gives you the most volume, biggest bang for your buck if you're only allowed one carry-on. Nice real life application to why you might use this. Good luck doing all that kind of math for something so simple, right? Just pick.
Try measuring it for a backpack. You'd be like,
I know. Especially since a backpack squishes usually, unless you get way overstuffed. Okay, so some definitions though. I'm going to give you a general picture of a cubic function. So we'll have something like, similar to what we just did, right? We'll have some key points on here. We have these three. What are these 3 points called?
the x values.
Not x values. Close. X what? X intercepts.
Okay.
You can also say it's values for x, which y equals 0. For which, let me, to make that a little bit more, make sense in the English language, for which y equals 0. The intercepts, right? That's here, and here, and here. That's where y equals 0. Okay? We have some other key points in this graph. We have up here would be called a relative maximum. For
Oh yeah.
Why?
I opened the door and she looked at me and then ran the other direction. And then he was just playing around outside.
poor Hunter. He's
No.
fine. He's fine. Okay. Why is that a relative max? Why not just maximum?
Because the other line on the
Relative
left
to
goes
what
up.
the other
The other side of it still is continuing up. So relative is in like, yeah, part of it's going to continue to go up. So it's not actually a maximum, but we say relative is in like it's a bump there somewhere. So if we have a relative maximum, what do you think we might call this point down here?
Minimum max.
Relative
Or
minimum.
relative minimum, right?
Yeah.
Right, which is also for a value of y. Relative minimum value of y, again, because it's going down further on the right side. So we have to look at the key points. I want to say, off the top of my head, I think they're called inflection points, if I remember correctly. Okay, moving on to example 4. Can you see this color okay?
No.
No, okay. Switch to something darker. All right, find the zeros of y equals x minus 2, x plus 1, x plus 3. Then
Wait, say it again.
graph. Find the zeros of x minus 2, that's a bubble,
Mhm.
times x plus 1, and x plus 3. Who remembers our zero product property? I say
Like,
it
is
slowly
like
for
the-
a reason.
Is it like the
Oh, everything adding up and equals 0?
Not adding up. what is-
Multiplying?
Multiplying.
Product.
Right, product. Product means multiplying. So it means that a product is 0. When that's the
so
case.
x take away 2 equals 0?
Well, hold on, hold on. Right, so when
So
that's the
equal to
case,
0.
some factor or all the factors have to be 0, right? When this is true,
Oh yeah, because it's multiplied by 0. Yeah.
right, one or more factors equals 0. Right, so either this first one, second one, or third one, or all of them are 0. So literally all you have to do is take each one of those factors and set it equal to 0. When is it 0? X minus 2. When does it equal 0? 0, not a 3. Well, you can do it in your head, or you can write plus 2 plus 2. I'm showing you what I'm doing in my head. On the next ones I won't. X equals 2. So that's one of the zeros. There will be 3. It's a cubic. There should be 3 zeros. We have x plus 1 as another factor. So then, when it equals 0, x would equal negative 1 there, right? Another factor was x plus 3. If it equals 0, then x would be negative 3. Negative 3 would make that factor 0, right? You can think in your head, if I take that negative 3 and plop it into this equation, that factor would equal 0, therefore the whole thing would equal 0. That is one of these points on the graph. Does that make sense?
Yes.
Because y equaled that whole thing. When y equals 0, that's that part of the graph.
Mhm.
It's a really important part for when you're graphing. So I can even guess, like, I don't have to jump to my calculator right now. I can sketch a quick graph knowing that these are my zeros. I can go to x equals negative 1, x equals negative 3, and x equals 2, and put those points there. I don't necessarily, I'm going to erase these. Don't copy this yet. I don't necessarily know if the graph is doing this or if the graph is doing this. Right?
Yeah.
So you have to
There are
go-
ways as you practice this and you do this more and more and more that you would know. I know that the graph of y equals x cubed is pretty basic of looking like this. A positive x cubed would start on the lower side on the left and end on the right upward. So I have some idea then, because of that knowledge, that this teal graph is more likely accurate than the yellow graph. We're not going to use that one. I'm going to erase all this and clean it up. But I just want you to see, like, I have some idea, right? Let me get rid of a bunch of this stuff here.
And when would it be the other side?
When the cubed part was negative, so y equals the opposite of x cubed would look something like this, right? That would be a parent graph. We haven't talked about parent graphs with this yet.
Okay.
Okay, so if you then go jump to your calculator and you can plug in exactly like this, because my guess is you don't actually want to multiply it out, type in those 3 factors, and then we can go to the table. We don't need
You
to,
put
like,
it in y equals.
yep, put it in y equals. And that will allow you to go to your xy table. And hopefully it's set up as an ask.
Where do you go to the table?
It should be second something, I think.
Second.
Let me see. Where is it? Second graph.
Oh.
Second graph above it is the table.
So I have this in y.
What?
Go to. Go arrow down and press enter. Oh, you don't have anything in there. Delete
Oh.
that. Delete that arrow though. I don't know where that came from. Yep. And come up here and type in your equation into y1.
What's the equation? Just the x plus.
Yep.
Oh.
Yeah, the x minus 2, x plus 1, x plus 3, all in each of those in parentheses. So then if you go to your xy table, and hopefully you have it set to ask, not automatic, go in to put something to the left side of the -3 because we know -3 is a 0, so we want something over on this side over here. And we want something in between to know which way it's going.
Why don't you plug in these 3 points?
Not just 3. So listen, I want something to the left of -3, in the middle of -3 and -1, in the middle of -1 and 2, and to the right. Did you catch all those? So I'll put some numbers on here. So like something like -4, -2, 0, and I don't know,
2.
3. I'm picking some. You can pick all of them if you
I don't
want.
understand how to go to that
Go to table.
I-
Second.
I know it keeps saying error.
Oh, wait, is that what it's supposed to do?
Oh, because you don't have another parentheses. You're missing a parentheses right up there.
That's not what it's supposed to do, right?
It's like that, right?
What did you? Oh, where did that come from?
Oh yeah.
There you go. Okay, now you're there.
Alright, can I do those?
Yeah, I don't want the
numbers?
graph. I want the table. So go second graph.
Wait, what'd you do for your x and y?
So for the x's, I want you to put in -4, at least these. You can go every single one if you want to.
Alright, -4. Probably
Yeah, I
negative.
want the table though. Go second
Negative
graph.
2.
So if you put in -3, you better come up with 0. I already know that. If I put in -1, I better come up with 0. If I put in 2, I better come up with 0. Those were my zeros, but you can check it.
Oh, you're getting stuff out of it.
Yeah, that's why you're using your table. You're telling your table, if x equals
How do I
-4,
clear my whole table?
you don't need to. Just type over top. Go to the x. Type stuff in. Type in -4.
Yeah, I have all these things.
Cool. Tell them to me. -4 was,
-18.
okay, and -3 was 0.
-2 is 4.
Uh-huh.
0 is -6.
Uh-huh.
3 is 24.
Okay.
5 is
That's
140.
that's good. I don't need to go way high because that's way off my possible screen here.
Yeah, okay.
So this gives me an idea, bless you, that this side over here is going to be pretty far down pretty quickly, right? So my graph will be here, but it's going to jump really far down really fast, right? So it's going to jump fast. And then I'm going to have a 0. In between, at -2, it's going to go up to 1, 2, 3, 4. So I'll have a relative maximum there. It's going to come back down to 0. And then between -1 and 2, I put in a 0. At 0, we had -6. 1, 2, 3, 4, 5, 6. So I'll have a relative minimum. It'll go back up to the 0 and shoot sky high. So you're getting some key points of your graph there with that, right?
Mhm.
And flying through a bunch of pretty important information. So try to pay close attention to it or rewatch this example. Lots of important stuff there. All right, factor theorem. Ready? You were done with geometry. You thought you were done with factors, right? Not quite. Okay, the expression x minus a is a linear factor of a polynomial if and only if the value of a is a 0 of the related
Just making kids cry today.
polynomial function. In other words, what we just did, this expression here is a linear factor if it gives you a 0 in the related function. Okay? Relating it back to what we just did. Can I move this?
Mm-hmm.
Okay. Can I move this?
Mhm.
Okay.
No,
All right.
you can't.
Example 5, you ready?
Nope.
Well, get ready.
Oh my goodness, how many examples are there?
One more after this. You'll be okay. Example 5. I know, it's a long one. Write a polynomial function in standard form with zeros. So write a polynomial in standard form with zeros at -2, 3 and 3. Oh, they're throwing in what's called a double root. 3 and 3 are the same, but there's two factors that are involved in that. Okay, so
Would you
negative 2, 3, and 3. So remember where we got those zeros from? This part here. We had a 0 at 2. Well, look at the
Oh,
factor that
that's
it
what
came
that's
from. It was x minus 2, right?
So you're
So you
gonna
just
do
switch the
opposite?
sign.
Uh-huh. So I'm giving you the zeros. I want to know what's the factor, okay? So so negative 2 would translate to what? What bubble?
positive 2?
Okay, so x plus 2. And then the 3 would be x
Minus.
minus 3, right? And same thing with the second 3, x minus 3. The directions say to write it in standard form.
Oh, I
Standard
see that
form.
now.
So in other words, we need to do what?
We have to do that thing that we did in example
opposite of it.
one.
The multiplying it out thing,
Get
right?
it out.
Now I see this right here.
Nothing's divisible by 10.
They're the same. We've done those a ton.
So you can just
Square
square
it.
the bubble.
You can square the bubble if you remember what to do correctly. It does
Square
not
root it.
mean, and it does not mean you square this and this individually. It still means you FOIL it out, but there was a pattern to it.
Oh.
Of it was, of course, the x squared, and then this and this gave you your doubled in third term thing, right? So it would have been, sorry, not plus, minus. It would have been minus 6x. And then plus 9. If you don't understand like that pattern that we had there, just multiply it out.
Yeah.
X
Okay.
minus 3 times x minus 3. I don't really care. So you'd say x squared minus 3x minus 3x plus 9. Those two combine to be negative 6x. It was a pattern of perfect square trinomial.
What do you do with the 9?
It's just plus 9. It's still
I
there.
thought
It's
that
hanging
was
out
nine.
there.
Okay. There we go.
And I still have the x plus 2 out front that I need to multiply out. So if I start doing that, I'm going to use a different color here. X, oops, wrong thing.
X times negative 6x.
X to the third, what? Oh, I didn't do that yet. And then minus 6x squared. I'm going to get rid of my grid because it's a little too hard to see all that stuff. And then x, 9x, plus 9x. So far so good?
Okay, you have x to the third minus 6x squared.
Mm-hmm. Plus 9x. And then I need to do the 2 times everything, right? So I would have plus 2x squared minus 12x plus 18. And then I need to combine like terms. I'm going to use those shapes again to show where my common terms are, like terms are. There's the x squared term, and I'm including the sign in front of it to remind me if it's positive or negative. And then I have the, let's see, I'll use yellow, I guess, ugly colors here. Those are like terms. So when I write it all, I have x to the third,
Negative 6x plus 2x.
which gives you negative 4x squared, and negative 3x, and positive 18.
What did you do to your kids?
I don't know. I don't know. Okay.
So sad.
All right. Any questions on that one? Okay.
They just need puppies over there. I think.
Maybe they need puppies over there. All right. So, all right. A repeated 0 is called a multiple 0. That was this one here. There was a repeated 0 within here. This one.
Yeah.
It was the 3 and the 3. I've also heard it called a double root because there's 2, or a triple root if it's 3 of them. A multiple 0 has a multiplicity equal to the number of times the 0 occurs. So this has a multiplicity of 2.
Because wouldn't that be the same point on a graph?
Yes, it would be, exactly. So this gets kind of tricky when this is the parent graph, right? Y equals x to the third.
Mm-hmm.
It only crosses it once,
Mm-hmm.
right? But we've been talking about how when there's a third degree, there should be 3 roots. So this one would be a triple 0. Triple 0, or a multiplicity of 3, right? These are words that like I want you to be introduced to. I've never used them. I've never heard them used. I've heard double root, triple root, whatever.
Or repeated zero.
Yeah, it's a repeated zero, right. But I want you to at least have been exposed to it. All right, so example 6. Our last one. Find any multiple zeros of x to the 4th plus 6x to the 3rd plus 8x squared
You can divide by
and
2x.
state and state what did I say? The multiplicity. So Lily, what were you saying? They all have factors of some kind of common factor, right? What's the greatest common factor among them?
4. I mean, not 4. I thought 4.
What can they all be divided by?
2.
2.
Not 2. There's no 2 on the
X
first
squared,
chart.
I mean.
Yes, x squared.
Ooh.
They can each be divided by x squared, right? So we're going to factor that out. Factor out GCF. So we'll have x squared. If I factor that out, take it out of, divide it out of each of
Wait, what
these,
does GC have?
greatest common factor.
Oh, okay. I was like, where's the G? I see it.
So we would have x squared plus 6x plus 8. Did I miss anything?
Mm-mm.
Wait, don't you have the, you have x squared? Oh, you do have x squared. I
Mhm,
missed that part.
mhm.
I was like, what?
So then I need to factor that trinomial. If it helps to do it in the box, do it in the
X
box.
squared.
Just the 6x and the 8.
Well, x squared and the 6x and the 8,
Okay. Oh, yeah.
right? So I'd have x and I'd have x. And in order to get these two to total 6, I would need a plus 2 and a plus 4. 2x plus 4x would give you the 6x in the middle. So here's one factor and the other. So the total factored form would be x squared times x plus 2 times x. Ah, that looks good. Plus x plus 4. If it helps to see all of the zeros here, you can expand the x squared to be x times x. There's 2 factors there. Times x plus 2 times x plus 4. Do you see any what I call double roots, or what your book is calling multiple zeros? Where would you have zeros here?
X times x?
Yeah, so this one and this one, if this could be 0, the x could be 0, the x could be 0, the x plus 2 could be 0, the x plus 4 could be 0. Is there any point at which the same number will make 2 or more factors equal to 0?
Those 2.
Just those 2, right?
Yeah.
So, the number 0, I'm writing out the words so it doesn't look like an O, is a multiple 0. With a multiplicity of 2.
We're done. I don't know why, but like looking at this stuff makes me so happy. Like it's just like so nice.
I do want to go over this quick little box down here because
Summary?
it is a summary of like basically vocabulary about polynomials that I want you to be comfortable with any of these meaning the same thing, okay?
Mm-hmm.
So equivalent, I can't spell. I'm going to highlight some things after I write it to point out what I'm talking about. So if I said something like, I'm just making these up, right? That's all the same expression I'm talking about, all said in different ways. -4, you can put this in quotes if you want, your book didn't, but I am. -4 is a solution of x to the, x squared. X squared plus 3x minus 4 equals 0. -4 is a solution. In other words, -4 would make that a true statement. It would be 0 then, right? another statement that means the same thing. Negative 4 is an x-intercept of the graph of y equals x squared plus 3x minus 4. So again, I'm going to say negative 4 is an x-intercept. These are all very important, like related things. They're all meaning the same thing, just said differently. Negative 4 is a 0 of y equals x to the second plus 3x minus 4. Where you can highlight negative 4 is a 0 of that equation. Means the same thing. I need to have quotes on all the end of the rest of these, right? In the last one, x plus 4. Your book doesn't have parentheses, but I'm going to put parentheses there. Is a factor of x squared plus 3x minus 4. These all have more or less the same meanings, because if it's a factor, the factor is going to give you a 0. The 0 gives you the x-intercept. We call those solutions. They're all interchangeable. So if you see in the directions anywhere, find the solution, find the x-intercept, find the zeros, find the factors. It all means the same thing. The end goal, a friend of mine oversimplified Algebra 2, but it was kind of funny to me at the time. The goal of Algebra 2, I don't care what kind of crazy graph you have, is to find the x-intercepts. The whole entire goal. I'm like, okay, it's not that simple, but it kind of is. Because really, you're going to see these phrases over and over and over and over and over. Find the solution. Find the intercepts. What are the intercepts? What are the key points? Key points being intercepts. Yes?
Negative 4. No.
I mean, yeah, sure. Negative 4 isn't always going to be the actual solution, but it's actually an example of it, right?
No. Yeah.
Questions then?
Are we done?
We are finished, yes.
That's a pretty good question.
Thanks for joining us.
Look at the stretch.
All right, stick around for puppy pictures.